Simplify. Express answers in lowest terms and indicate non-permissible values as restrictions on the variable. So in both of these examples here, we are adding rational expressions. We're adding quotients. Whenever we're adding quotients, we need to ensure we have the same denominator. So we're going to first determine the lowest common denominator. And a simple sort of technique to determine the lowest common denominator is to simply multiply the two denominators. So it's going to be 3 times x minus 2. So our lowest common denominator here consists of two factors, 3, the monomial 3, and the binomial x minus 2. Now we're going to put the expression on a common division line with that common denominator. And then for the numerators, each numerator we need to multiply by the missing factor in that original denominator. So the original denominator here was 3. But the factor that's missing here from the lowest common denominator is x minus 2. So that means we have to multiply the numerator by that missing factor, x minus 2. Same thing for the second numerator, for x. The missing factor in the denominator is 3. So we're going to go 4x times 3. Now we're going to expand the numerator. So we get x squared minus 2x minus 5x plus 10. So that's if we're foiling these two binomials, plus 12x. The denominator remains factored. Okay, now we can combine some like terms. So in the numerator we have one x squared term. So we have what I often do is I cross out the terms that we have combined. Then we have negative 2x minus 5x, that's negative 7x, plus 12x, that's going to be positive 5x. And then we're just left with plus 10. And the denominator is 3 times x minus 2. Okay, so at this point we are almost done. The only thing we might want to check here is if there's any way we can factor this trinomial in the numerator. So if we want to factor this trinomial, we're looking for two numbers that would add to 5, but they would multiply to 10, and there are no such two numbers, which means we're done here. The only thing we need to do now is to identify the non-permissible values and then state them as restrictions on the variable. So in this case, x cannot equal to positive 2, because if it does, the denominator here is going to become negative, 0, which it cannot. And then we go back and check if there are any additional non-permissible values, and they are not in this case. So that's our final answer. In B, again, we need to find the lowest common denominator first. We can do that by simply multiplying the two binomials that are in the denominator. So p plus 2 times p plus 3. We put the expression on a common division line with the lowest common denominator. And the first term in the numerator, p minus 1, has to be multiplied by p plus 3 because that's the missing factor. The second denominator, p plus 2, has to be multiplied by p plus 2 because that is the missing denominator. Now we expand the numerator. So we're going to apply FOIL twice. So the first time we're going to get p squared plus 3p minus p minus 3. And for the second pair of binomials, we're going to get p squared plus 2p plus 2p plus 4. The denominator remains in factored form. Now we can combine like terms. We have 1p squared plus another p squared. That's going to be 2p squared. Then we have 3p minus p, that's 2p, plus 2p is 4p, plus 2p is 6p. And then we have the numerical constant. So negative 3 plus 4 is 1. Denominator is p plus 2 times p plus 3. And in the numerator, we now have a trinomial. So again, we want to double check that we cannot factor this trinomial. So if we would be able to factor this trinomial, we would be able to find two numbers that would sum to 6. If we add them, you get 6. And if you multiply them, you get 2. And there is no such two numbers, which means that all we need to do is state the non-permissible values as restrictions on the variable. So p cannot equal to negative 2, because if p equals negative 2, this binomial will equal to 0. Negative 2 plus 2 is 0, and the whole denominator would equal to 0. P can also not equal to negative 3, because if it does that, then this binomial will equal to 0. 0 times 0 is 0.